So exponential growth occurs when a quantity increases / multiplies by the same rate over time. So we have this formula that I showed you last week, a times b to the t. When I talked about when I talked about b, if b is less than 1, what happens? It decreases. If b is greater than 1, what happens? It increases. So if we look up here, it's 1 plus a number. This is always going to increase. It's 1 plus the rate. So A stands for our initial amount. The amount we start with. R stands for percent increase as decimal. As a decimal, we need to put it in decimal form. T is time. B is our ratio. So after we figure out our percent increase, we can simplify it to the second equation. So we're going to do number 1 as an example. So y equals our original amount, our initial amount is 1,400. I'm following this formula right here. 1 plus our percent. So the decimal form of 9% is 0.09. Then I'm going to raise it to the time, t. This talks about 25 years. So I have this filled out correctly. I have my initial amount, 1 plus the percent increase, raised to the time. I can simplify this. $1.09. So that's simplified, raised to the 25th power. So this means I'm going to be multiplying by 1.09 over and over and over 25 times. Then multiply it by 1,400. So in our calculator, we type in 1,400 times. Then you're going to type in 1.09. You're going to hit this power button. 25, I'm raising it to the 25th power, equals. So, if I type this in my calculator, if I have an investment of $1,400, it increases by 9% each year. I will have $12,072.31.
Wait, what did you do? You did the parentheses first?
That's PEMDAS, yep.
1,400 times.
Then the power, then you multiply by the number in front. Bless you. So let's try number 2. The cost of tuition at a college is $12,000, and it is increasing at a rate of 6% each year. Write an exponential growth function to model the situation, then find the tuition after 4 years. So we need to create this model using this formula.
Y equals 12,000.
So, yep, our original amount
1 plus 0.06
plus the percent increase, yep,
to the 4th power.
correct, because that's our time. So this can be reduced to 1.06 to the 4th power. I don't know why I put a 1 there. Now I can type this into my calculator. So 12,000 times 1.06. Now I need to raise that. So I hit this button to the 4th power. and equals
15,000.
149 and 72 cents. Now, the reason this is 1.06 is if I was to make a table in this, which I want you to do, down here. Here's my x value. Here's my y. If x is 0, I started with 12,000, right? I multiply it by 1.06 raised to the 0 power. Anything raised to the 0 power is 1. 12,000 times 1 is just 12,000. Okay, after year 1, I'm going to take my original amount and multiply it by 1.06 to the first power, because it's year 1. Year 2 is 12,000 times 1.06. That's the year before it, right? To find the next percent of that, I multiply it by 1.06 again, which is the same as just writing that squared. If I want to know if I'm going to go up 6% from this, if this is going to increase 6%, then I have to multiply it by 1.06 again. So I take the amount I had before, which is 1.06 times 1.06. Here's what I had before. Multiply it again by 1.06. So that's the same as 1.06 cubed. Day 4, or year 4. I see a pattern here. I don't want to write this out again. It's 1.06 to the 4th power. I'm multiplying by it 4 times. This is where the formula is derived from out of a table, which we worked on when we did the zombie one. Kept multiplying by 2 over and over. Okay, you can put this aside and take out your packet.